Hi guys, in this video we're going to have a look at solving functions. So if you haven't already had a look at solving equations using the balance method video, definitely have a look at that because we'll be using a lot of that. Also, as well as that video, solving quadratics by factorizing will also be cropping up as well. So if you haven't seen those two videos, definitely have a look at those before having a look at this. Okay, so let's get cracking. So here's my function, f of x equals 3x plus 7, and we need to solve f of x equals 13. So all I'm going to do is, if 3x plus 7 is f of x, I'm going to set this equal to 13. So let's do that then. So 3x plus 7, which is the function, and the function is equal to 13, so I just set it equal to 13 like so. Now to solve it like an ordinary equation, so I want to get rid of that plus 7 by taking away 7 to both sides, which leaves me with 3x equals 6. Once I've got that, I can now get rid of my times by 3 by dividing both sides by 3, like so. And that leaves us with x equals, and then 6 divided by 3 is 2. And there we have our answer, x equals 2. You can make that a bit bigger down here if you wish. Okay, next one. So we've got a function here, which is 6x plus 2, and we have g of x, which is equal to x minus 5, and we've got a composite. So this is when you need to have watched the composite functions video, because what this means is I put g, which is x minus 5, into f. So if I just put a bracket around there, I'm going to substitute g, this x minus 5, into these brackets here. So let's do that. So I'll have my 6, which is obviously there, then I'll have my bracket, and what goes inside the bracket is my g of x, which is the x minus 5 there. I can then close my bracket, and then I have that plus 2, and then that is the composite function here, and that is equal to 86. Okay, so if you've seen the composite videos, you'll know what I mean when I do that. What we do now is we just solve it. So I've got a single bracket, so I'm going to expand that single bracket. You can use your grid if you want to for expanding single brackets, but 6 times x is 6x, and 6 times minus 5 is minus 30. Oops. And then I have my plus 2, and then I have obviously the 86 still. A little bit of tidying up before we do anything further. So I've got my 6x, and then minus 30 plus 2 is minus 28, and that equals 86. There we go, that looks a bit neater. So there's just a standard equation like we did up here. So I'm going to solve it again using the balance method. So I'm going to get rid of that minus 28 by adding 28 to both sides, which leaves me with 6x, 80 plus 20 is 100, 6 add 8 is 14, so that's 114. Once done that, last step, get rid of that times by 6. We do that by dividing both sides by 6. So in this case, x equals 114 divided by 6. Well, 20 times 6 is 120, so that must mean that x is 19 for this one. So our solution for this one, x equals 19. Next one, again, composite functions. Got the f of x. So I'm basically putting the function f into itself again. So I'm going to be putting the 6x plus 2 into these brackets this time. So let's do that. So I'll have my 6, then inside the brackets I need to put the function, which is 6x plus 2, and I close the bracket, and I've got my add 2. So it's exactly the same thing I did here, but instead of putting g into it, I put f into it. And that is equal to 14. Same steps as down here, so I'll just expand that bracket. Again, you can use a single bracket grid to help you with this. But 6 times 6x is 36x, 6 times 2 is 12. I then have that plus 2, and it's still equal to 14. Once done that, just like we did down here, bit of tidying. 36x, 12 add 2 is 14, equals 14. And we just solve it same way. So I've got plus 14, I need to get rid of it, I'll do the opposite and take away 14. Don't forget, do it to both sides. So 36x equals 0. Then I need to divide by 36, again both sides, to get rid of that times by 36. And in this case, x will equal 0. Okay, so you've got two function there, f of g, so composite function that way, and f of x is equal to 14. So there's two composite solving functions for you there. Okay, let's start looking at some quadratic. So here we've got our little x squared going on here, and this is our function g of x, so 2x squared minus 10, and we need to solve when the function is equal to 8. So this one's not too bad. So I can literally just go, right, 2x squared minus 10, which is the function, and that's equal to 8. A little bit of rearranging and solving, so I'm going to get rid of that minus 10. To do that, I do the opposite and add 10 to both sides. So I'm left with 2x squared equals 18, like so. And I got that times by 2, so I'll get rid of that by dividing by 2, both sides. So x squared equals 9, and then I just need to square root both sides. So x equals the square root of 9. And everyone will go x equals 3, which is great, but don't forget if you square root something you have a positive and a negative. So it would also be x equals minus 3 as well. And remember, because minus 3 times minus 3, so minus 3 squared, gives you 9. So whenever you square root something you have two answers there, so just be careful of that one. You have two solutions, x equals 3 and x equals minus 3. Okay, so let's step it up a notch and have a look at some of these. Okay, so here we have our function again, and this time we have to solve this. We've actually got to substitute x minus 2 into our function. So again, I'm just going to stick brackets just around the x. I'm ignoring that squared and putting it just around the x, because I'm substituting this into there. So when I do that, inside the brackets I have x minus 2, then outside the brackets I have squared and the plus 1, and that equals 10. Okay, so this is what I need to solve. So obviously I have a double bracket expansion do, so I'm going to just come over here and draw my big grid over here and stick my x minus 2 there, x minus 2 there, and don't forget when you're expanding brackets we're multiplying. So x times x is x squared, x times minus 2 is minus 2x, minus 2 times x minus 2x, and minus 2 times minus 2 minus times a minus is a positive. Don't forget to tidy up this. Minus 2x, take on the 2x, is minus 4x. So expanding that bracket, this is what we get. We have our x squared minus 4x plus 4, which is this bit here, expanded, but I still have my plus 1, don't forget that, and it's still equal to 10. So I'm going to do a little bit of tidying up and just add the 4 and the 1 together. So that's going to give me x squared minus 4x still, but 4 add 1 is 5, and that equals 10. So again, this is looking like our quadratic, and to solve a quadratic it needs to equal 0. So if it needs to equal 0, I need to get rid of that 10. So I'm going to take away 10 to both sides. So that's going to leave me with x squared minus 4x minus 5 equals 0. So now you can solve this quadratic, so you could do that by using the quadratic formula, but if it's non-calculator you'll have to resort to factorising, and that's exactly what we're going to do now. We're going to do it without the calculator, so we're going to factorise it. So here's my big grid. I'll do the same thing. I'll put my x squared in there, and I'll put my minus 5 there, and start to fill in what are the ones I know. Well, x times x is x squared. I need numbers that multiply to get to 5. Well, there's only one option there, as 5 is prime. It's 1 and 5, so I'm definitely going to be using that one there. How do I use 1 and 5 to get minus 4? Well, it's going to have to be minus 5 and then add 1. So when we fill in the rest of this, I'll have minus 5x plus x. So when I simplify this, I will have minus 4x, which is what I want, and I've got my minus 5, and I can check that 1 times by minus 5 is minus 5, so yep, that works. So when we factorise this, we'll have x minus 5 in one bracket, x plus 1 in the other bracket, and then it's equals 0. So if you've seen my video on solving quadratics via factorising, you'll know that we need to set this bracket equal to 0. So what value of x makes this bracket 0? Well, that would have to be 5, because 5 take away 5 is 0, and therefore 0 times by whatever's in here gives me the answer of 0. And we apply the same trick for this bracket. What does x need to be to make this bracket 0? Well, that's -1, because -1 plus 1 is 0, and therefore 0 times by whatever's in here gets me my answer of 0. So two solutions there. 5, x is 5, and x is -1. Okie dokie, so let's step it up again. We're going to have g f of x and f of gx, so basically two composite functions, and we're going to set them equal to each other. So let's concentrate on this one. I'm going to put f of x into g, so our function g, so I'm going to put my brackets just around the x's there, again excluding that squared, and I'm going to put my f function, which is the 3x plus 1, into those brackets. So let's do that. So I have 3x plus 1 inside the brackets and then just squared. So that's this bit done. Now let's do this bit where g goes into f. So the x squared goes into those brackets there. So that's going to be 3 bracket x squared bracket plus 1. So I've just put the x squared inside those brackets like so. So there's my basis of the question. We now need to solve it. So again, I need to expand this double bracket here. So I'll do that over here. So I've got my 3x plus 1, 3x plus 1. So 3x times 3x, yep, we're timesing. So 3x times 3x is 9x squared. 3x times 1 is 3x. 3x times 1 again is 3x, and 1 times 1 is 1. A little bit of simplifying, 3x plus 3x is 6x. So if I expand this, I have 9x squared from there, my 6x, and my 1. And that's going to equal, again, this is just 3, and then in brackets, x squared. So if I expand that just as a single bracket, it's quite simply 3x squared, and then obviously the plus 1 at the end there as well. So what's my next step? Well, I've got 3x squared on this side, 9x squared on this side, so I'm going to take away or get rid of the smallest one. The smallest one is the 3x squared. So I'll take away 3x squared from both sides, which will leave me with 6x squared plus 6x plus 1 on this side, and on this side I'll just be left with 1. So again, it's looking like our quadratic, but we can't solve anything unless it's equal to 0. So I'll need to get rid of that 1 on this side. If I get rid of 1 from this side, I have to do the same thing on the left-hand side. So that's 6x squared plus 6x, and then 1 take away 1 is nothing, so that's fine. And we have our equals 0. Now what you notice is when we look at this and we try to factorise it, this will actually factorise into a single bracket. So how we factorise single brackets, we are after the highest common factor, which in this case is 6, because 6 and 6, the highest common factor is 6. And I break this down, so 6, don't write x squared, we write x times x plus 6x. Highest common factor was 6, so 6 goes on the outside. 6 times what gets 6? Well, that's 1. 6 times what gets 6? Well, that's also 1. And I'll put my add in there before I forget. So I've dealt with both the numbers. X is on both sides, so I cross off an x on both sides and bring one out there. What's left is my x. So when I factorise this, I have 6x on the outside, and in brackets, 1x will simplify to be x, and obviously I have my plus 1, and it's still equal to 0 crucially. So what values of x do I need to make this work? Well, this x here, if that's 0, 6 times 0 is 0, and then 0 times by whatever is in here gets me the answer of 0. So that's one solution. And my other solution is, what does x need to be to make this bracket 0? Just like we did over here. So that would need to be -1, because -1 plus 1 is 0, and therefore 0 times by whatever's here gives me 0. So my solutions for this question, which was very juicy, x equals 0 and x equals -1. One more really juicy question to have a look at now, which is this one here. So last one of the video, we have inverse of f, inverse of g, set them equal to each other, and solving it. So quite a lot to do here. This would be a big marker in an actual exam question. Excuse me. So the first thing we're going to do is work out what the inverse of f is. Okay, so what I'm going to do is, instead of calling it x squared minus 17 equals f of x, if you've seen my inverse functions video, which you definitely need to have a look at, you'll see that what I do is I set it equal to y, where y is the output and x is the input. And all I do is to work out the inverse is to swap them round. So I'll say, right, y is now x because the output is now the input and the input is now the output. So I'll have that. And then all I do is I rearrange this to make y the subject. So the first thing I would do is add 17 to both sides. So I would have x plus 17 on the left hand side equals y squared. And then all I would do is square root both sides to get rid of the squared there. So I'll have the square root of x plus 17 on the left hand side, and then that equals y. So the inverse function here would be the square root of x plus 17. I now need to find out the inverse of g. So again, same thing, I'm going to set it equal to y. I'm then going to change the input to the output and the output to the input. So y becomes x and x becomes y. And again, I'm going to rearrange it to make y the subject. This one's nice and simple. All I need to do is take away 3 from both sides. So x minus 3 equals y. So inverse of g of x, sorry, is just x minus 3. Once we've got our inverses, we can now form our equation by setting them equal to each other. So I have the square root of x plus 17 is equal to x minus 3. Now we're in business, we just need to solve it. Let's get rid of that square root. To do that, I'm going to square both sides. So on the left hand side, I'm just left with x plus 17, get rid of that square root, which is good. And on the right hand side, I have x minus 3, but that's all squared. Everything needs to be squared, hence why I've put it in brackets like so. Once we've done that, we just need to expand it. So here's my big grid again. So x minus 3 on both of them, and we're still timesing, so we're expanding a bracket. So we're going to have x squared minus 3x minus 3x minus times the minus is a positive, so that's going to give me plus 9. And then we just need to simplify that. Minus 3x, take another 3x is minus 6x. So what we're left with, well, on the left hand side here we have x plus 17, and when we expand the bracket we have x squared minus 6x plus 9. Now, it looks like a quadratic. Well, it is going to be a quadratic, but we need to solve it. We need to have it equal to 0. So I need to get rid of all of this on this side, make it equal to 0. So let's start off with that x and take away x to both sides, like so, which will leave us with 17 equals x squared minus 6x, take another x is minus 7x, be careful there, plus 9. And then I can get rid of this 17 here by taking away 17 both sides. So it's now equal to 0, which is what we were after to solve it. We'll have our x squared minus 7x, and then we will have minus 8. Again, you could use the quadratic formula to solve that quadratic, or if it's non-calculator, you would factorize it. And again, this is non-calculator, so let's factorize it. So here's my grid. Always start with the same bit, x squared and my minus 8 there. Well, x times x gets me x squared. What numbers multiply to get 8? Well, I've got 1 times 8 and 2 times 4. Which pair can I use to give me a 7? 1 and 8 will get me a 7. But how will it get me minus 7? Be careful, minus 7. Well, that would have to be minus 8 and then plus 1. So that would give me minus 8x when I fill this in, plus x. And when we just check it, and always check it, minus 8x plus x is minus 7x, which is what we want, and 1 times minus 8 is minus 8, so that works as well. So, putting it all back in, we'll have x minus 8 in one bracket, x plus 1 in the other. And then what are my solutions? Well, just as we've done before, what value of x will make this bracket 0? 8, because 8 take away 8 is 0, and then 0 times by whatever's in here will give me the answer of 0. So that's one solution, and in this one I'll have to have minus 1, because minus 1 plus 1 is 0, and therefore 0 times by whatever's in here gets me the answer of 0. So I have my two solutions. A very juicy question, that one, guys. Bit of inverse and as well as solving as well. So Hopefully that's addressed as many examples as you need to be familiar with how to solve functions. Again, if that didn't quite make sense, we've used factorising into double brackets, we've used composite functions, we've used inverse functions. Definitely look at those videos. Obviously expanding double brackets as well. So if any of that didn't quite make sense, definitely have a look back and refresh your memories at how to do those things if this was a bit tricky. But hopefully that helps, guys. Thanks for watching.